Welcome to Brain Vision.
We begin this question by calculating what is the net force that acts on the electron. And how can we do that? Well, remember that from Newton's second law, the net force is given by the mass times the acceleration. We know the mass of that electron. The mass of that electron is equal to 9.11 times 10 to minus 31 kilograms. Now, we have to determine what is the acceleration. And how can we do that? Well, take a look at the data. So the electron goes from 5.4 times 10 to the 5th meters per second to 2.1 times 10 to the 6th meters per second. Then the variation in the velocity is 2.1 times 10 to the 6th minus 5.4 times 10 to the 5th. And this happens while the electron was traveling a distance of 0.038 meters. So all we know is delta V and delta distance. How can we know what is the acceleration? We can use Torricelli's equation, which tells us that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. Then we have the following. The final velocity 2.1 times 10 to the 6th squared is equal to the initial velocity 5.4 times 10 to the 5th squared plus 2 times the acceleration times 0.038. Then we have to solve this equation for the acceleration. In order to do that, we have first to do some things. So we send this term to the other side to get the following. So we get 2.1 times 10 to the 6th squared minus 5.4 times 10 to the 5th squared is equals to 2 times the acceleration times 0.038. Then we have this, we can do the following. Send both the 2 and the 0.038 to the other side. So we get 2.1 times 10 to the 6th squared minus 5.4 times 10 to the 5th squared divided by 2 times 0.038 is equals to the acceleration. Then this gives us an acceleration of approximately 5.42 times 10 to the 13 meters per second squared. So this is the acceleration. Now we can go back and calculate the net force. The net force is then equals to 9.11 times 10 to minus 31 times 5.42 times 10 to the 13. Then the net force is approximately 4.94 times 10 to minus 17 newtons. And this is the answer for the first item. Now, on the second item, we have to calculate what is the strength of the force F2. And how can we do that? Well, note that the force F1 is pointing to the right and the force F2 is pointing to the left. So the net force is equals to F1 minus F2. The net force we know is 4.94 times 10 to minus 17. The force F1 we know it's 7.5 times 10 to the minus 17. And then all we have to do is calculate the value of F2. We can do that by sending this term to this side and this term to this side. So we get F2 is equals to 7.5 times 10 to minus 17 minus 4.94 times 10 to minus 17. And this gives us a force F2 that is equals to 2.56 times 10 to minus 17 newtons. And this is the answer of the second item.